Well, hi everybody. Um, Thank you for uh, having me speak tonight. I am really excited about this, and I have to admit, this topic is it's something that I've thought a lot about. Giving a presentation gives me the opportunity to share some ideas with you and some of the things we're doing in Hennepin County with this, but we're actually not doing that much. But I'll give some explanations. And I did truncate Jared's wonderful. We did have some back and forth about the title, but I stuck with just the brutal and wild history of extreme non-convective windstorms in Minnesota. They're going to blow you away. Um, we'll get down to business since I got a. It's good to be here. It's been a while since I presented for this group. I'm going to move my some Zoom Pro tell me the best way to move that little action bar out of the corner. Uh, the one that, it says mute, stop video, participants. Um,
I'm not sure how you can do that, to be honest with you, while you're sharing.
mm, all right. Well, I'm going to move it. I'm going to move it to the top, I guess. Anyway, so if you're wondering who I am, because I don't presume people on the call know me, on this meeting know me. I am a Minnesotan. I'm a former storm chaser. I was terrible when I did it, but that's how I probably know a lot of folks in this group was from my early days or the early days of storm chasing when I was more involved. I'm a public climate scientist. I work for the Department of Natural Resources. I'm a dad. My kids and I like roller coasters. I mean, we like them a lot. It's one of my guilty pleasures. I'm a cyclist. I'm a husband. I'm a loudmouth who likes to talk a lot. And your job is to not let me talk too much tonight. I really am coming here wearing two hats. So my full-time job is with the Minnesota State Climatology Office, where I am a climate change scientist. Uh, I do a lot of climate service. We work closely with the Weather Service and a lot of our other partners in what I think of as kind of the weather data production world. We're also consumers of weather data, and then we produce more information for our users out of that data. I also am involved. I actually oversee Minnesota's. It's about a 40 station agricultural mesonet, but it was kind of the first project I was given when I started with the DNR in 2015, and it's been a really interesting road because we're part of a hydrology group, and so we had to get a lot of equipment that hydrologists could work with. As a part-time employee on the side, I work for Hennepin County Emergency Management. Probably had met you probably had met Sarah Carroll or Emily Harrington. They're sort of the real meteorologists. I do some forecasting support for sure, but I put two colons in there. But I do little r research um, that helps the county and in particular emergency management kind of improve awareness and understanding of the potential for high impact events. I really do use what I understand about climatology and about the past, and then what I'm learning about the future from climate modeling to help with this. But a lot of times, yeah, it's just what do I'm basically asking the question: did you know that this could happen? How prepared are you for it? And you know, I I don't have to have the answer to how prepared you are for it. Usually, for the director Eric Wagi and deputy director Dan Bovitz, it's enough to tell them, "Wow, here's the frequency of these kinds of weather hazards across the region or across the county. Here's some things that we haven't had since this office has been stood up. Um, you should probably know about it. You probably want to plan for it." I'm not truly an emergency manager. I'm more like someone who supports emergency management. And I'm just going to remind all folks on the meeting to mute. If you're not me, mute. Okay. So a little more in the work I do, I have one unifying theme, which is really, and it took me a minute to figure this out, but what I like doing is identifying things that people didn't really know or understand, and then I try and convince them that it matters, that they should know about it. And I try and use data and evidence. But I mean, I think back to the work I used to do when I was a graduate student, and I was testing a kind of popular hypothesis about severe weather frequencies in or tornado frequencies in urban areas. And it was all, I don't even know how robust the research I was doing was. It was all the values seemed to be in kind of correcting pervasive myth about, tornadoes and severe weather. They'll avoid certain areas. And it turns out that it's a kind of myth that extends well beyond cities to almost any landscape that's sort of idiosyncratic. So a certain group will identify with a landscape. And if they haven't had a tornado and they're in a tornado prone region, they'll tend to believe there's something about that landscape that like makes the tornadoes not occur there. So that's one area. Uh, I'm really fascinated by probable worst case scenarios. So worst case scenarios are easy, and everyone is either studies meteorology or is interested in meteorology, and everybody can think about, wow, this wouldn't this be amazing or horrid or whatever. But uh, the actual worst case scenario that you're likely to experience is kind of a different animal. Um, so there's the sort of worst thing imaginable, which you probably won't experience, and then the sort of probable or plausible worst case scenario. And thinking along those lines, I've always enjoyed using climatology and meteorology and just weather and climate information to help people understand those. That's very much what I'll be doing tonight. I love the idea of reminding us of things that we forgot about, some big ones, big events. It's amazing how short our memories are, even when we study climatology and meteorology, we lose sight and we lose memory of the big events. And it's good to be reminded of them because, you know, sometimes I feel old, and then sometimes I look at the historic events, and I realize how little I've experienced, how little and how how much potential there is just in our climate in the years ahead. Um, so these are things that, the wonders of our past. This is all stuff that I like to talk about. I think I'll be bringing some of this together tonight. I suppose I should have a caveat also that this is very raw. I am really assembled this material for tonight. I've never presented it before. I had put it, I had put elements of it in the Hennepin County Emergency Management's initial hazard assessment. They were doing a mitigation plan, and I wrote a lot of the weather parts for their hazard assessment, just doing kind of what I do as a climatologist and as a little r um, research scientist, and had stumbled upon this topic and realized, okay, we better put this in because these events that I'll be talking about tonight are important, and they are almost never included in hazard assessments. And so, but there's going to be, when we get to the end, I'll just awkwardly end it. There's not a really tidy conclusion, but I'll be making the points that are important along the way. All right, so I want to give you an example of work that I do. Um, and you'll see on all these slides there's a sort of dual sponsorship, because this work that I'm presenting now is very much both hats for me. Most of the work I can keep pretty clean, but talking about history and bringing out historical documents and trying to make a climatology out of that is all a part of service climatology that I do for the State Climatology Office. But preparing and raising awareness over specific hazards that's really and helping for preparedness purposes is really the work I do for Hennepin County, and I can usually keep them pretty clean. There's some overlap tonight. Um, so it's hard to play this game on a Zoom call when I've got a single screen, but um, you know, if we were in an auditorium at John's conference, for example, I would ask everyone what we were looking at. And I don't know how many people would know, but we've got a pretty bad map that I made using the worst possible uh, technologies, but I'm showing extensive extreme wind damage in kind of a southwest to northeast swath across Hennepin County, a cloud of incredible damage in far northeast Hennepin County, and then sort of a swath of general wind damage around that. And it's annotated. And this was an event that resulted in a death, 10 pretty significant injuries, 2 with broken bones, 75 homes destroyed, and you can see all the other stats about it. And so I don't know what people are guessing right now. You can, I guess, put it in the chat. I'll count to 10. If you have an event date in mind, put it in the chat. And in 10, when I get down to 1, I'll switch slides. 9, 8, 7. By the way, I would only do this to a group of nerds, so I do expect some participation here. I know who you guys are. All right, 6, 5, 4, 3, 2, 1. Oh, I have to see. I can't see the chat. All right. This was July 3rd, 1983. This was something, this was one of the most incredible events I have studied. It was actually surveyed by the Fujita team. Brian Smith, in particular, flew over the entire damage path between about Wayzata and the northwestern Wisconsin. You can see on this map that there was a tornado outbreak in Wisconsin also. There was no small potatoes, but this this was essentially a massive windstorm. It was associated with a thunderstorm. It was a supercell thunderstorm with some Boeing elements in it. This was one that Bill Togstead had spoken a lot about back then, and this was a definitive severe weather outbreak. This is 1983. This is not the same as the derecho that came down I-94 about 2 weeks later and hit 117-mile-an-hour wind in Alexandria. This is a different one. This was actually more brutal. This produced what at the time was surveyed as F2 equivalent damage from downburst winds in a swath from the metro to northwest Wisconsin. Now, I know that survey wind estimate practices have changed, but at the time, they were 120 to 140 mile an hour wind gust estimates in that swath of predominantly non-tornadic damage, which is an incredible wind. And there was again, a confirmed F4 in Andover. So this is 1983. This is our most recent violent tornado in the Twin Cities metropolitan area. And you can, it's not that hard to find at least some kind of basic information about this event. But what I'm so fascinated as just someone who's always been interested in severe convective storms, what fascinates me is the level of destruction. I mean, the way that the damage was done with this particular event, just I can barely comprehend it. And if you go back to this map here, this shopping mall in Champlin, there were cars that were thrown through the parking lot presumably by downburst straight line winds. And what's interesting about this is it's not alone. When you go back historically, this was kind of one of the greatest thunderstorm events to hit the Twin Cities metro area, but it has some company historically. And there had actually been an event 3 years earlier in mid-July that went from the southern metro towards Eau Claire. I mean, and where it really got down to business was in Eau Claire, but I think it hit 86-mile-an-hour wind gust at Flying Cloud. So it was not exactly a joke here in the Twin Cities. So 1980 had one, 1979 had what at the time was considered the greatest severe thunderstorm outbreak in the Twin Cities metro. Previous to that, it was the one that hit the Wold Chamberlain Field in 1951. And before that, for those who don't know, there was just a massive complex that I wish there was some way to reanalyze it in August of 1904 that produced extraordinary damage, including 110-mile-an-hour sustained wind in downtown St. Paul with a gust to 180, which is still the strong before this always happened with these storms too, is the measuring equipment always blows away or breaks or gets pinged or something. So anyway, I like that stuff. That has nothing to do with most of what I'm talking about today, but it's an example of the kind of, standing in awe of our past, using it to educate us about what is absolutely possible here, and maybe helping us care about something that we hadn't thought about or cared about or understood previously. So today, here's what we'll get through, and we might not get through all of it. We're going to talk about these extreme non-convective wind events. Everything I had just shown was from a obvious, huge, big 60,000-foot thunderstorm. So we're going to have the background and do a few cases, a little bit of science, some possible indicators, and I don't know how much time we'll have for all of this. So let's go. So I want to start with a few years ago in March of 2017. You probably remember it because on March 6th, there were tornadoes in Minnesota, 3 confirmed, I believe. Now, they weren't massive tornadoes and they weren't particularly high impact, but it broke our record for earliest tornadoes that we know of. And that was something else. And it was relatively well forecast too. And of course, no surprise, if we're going to get a severe weather outbreak, especially in the spring, early spring, especially deep into one of the transition seasons, it's going to be associated with an extratropical cyclone. And so the next day got really, really windy. And I use that really bad with the little online coloring tools. So I did a terrible job of highlighting a story that we put up at the climatology office, but this is when Pierre the Voyageur lost an arm. You can see it there lying on the ground next to him. And this is because in the strong pressure gradient that resulted from the passage of the cyclone, the intense winds picked up. You can see that if you care to read the text, it was the winds were 30 to 40 miles an hour it was really the gusts in excess of 50, and it was the gust hitting 66 miles an hour at Grand Marais. Probably was comparable in the Two Harbors area where you'll find Pierre. Anyway, it was there was other damages. This was back, if you guys remember, when US Bank Stadium couldn't get its act together and was always losing tiles and whatnot. We had some more cascading tiles that day. So that's a strong regional wind event. Or more recently, we had what our office called the Holiday Lights Howler, this incredible blizzard from December 23rd, where we had blizzard conditions push right into the heart of the Twin Cities area. And that almost never happens. But I mean, it happened in 2018. And before that, it was the Halloween blizzard. And before that, it was 1983. It's pretty rare in any case. And you can see the public information statements from the Twin Cities and Duluth showing some of the wind speeds that were recorded. You got another 70 at Grand Marais, you got a 68 at Redwood Falls. You had some 60s in the Twin Cities area and 58 at our airport, and 60 miles in Duluth Harbor. So good windy event. Now, when we look at these are both, on the left, you have the 2017 aftermath. And I know you have to squint, but you see the strong low pressure system to the north, the cold front, and there had been a low closer to us that sort of cut off and occluded, and the main circulation moved north into Manitoba. That's the map on the left, and on the right is the daily weather map from early on the 24th. Both of them they're both strong cyclones with strong gradients. We had 55 to 70-mile-an-hour gusts. We had a little bit of damage in both cases. So the 2017 event produced, there was some trees down. There were a few power lines that went down. Um, and people's lights would flicker for a while. There wasn't much in the way of structural damage, but and it was similar in the 2020, the December blizzard. Similar, probably the biggest, most destruction was up in the Holiday Lights tour in Duluth, the Bentleyville lights. The whole village was destroyed, which is kind of a bummer because it was 2 days before Christmas. So, these definitely are due some respect, but these events, and I'm also going to throw in a couple from 2019 where we had some really good wins. These don't qualify. These would actually be the entry level for beginning to talk about really intense non-convective wind events. So these are impressive, but it's not what we're talking about here. So I want to, well, let's start with, I guess, some definitions here. We're talking about extreme wind, which is essentially, it's essentially in the region, basically in the Midwest, we see this happening 1 to 2 times per decade, where you get maximum sustained winds outside of the Buffalo Ridge, but kind of into almost any area, uh, 45 miles an hour. You get gusts above hurricane force, and you get a damage duration that goes from, in some cases 6 hours up to almost a day. And you have a window where the winds are incredibly intense that lasts 3 to 6 hours and a fairly large footprint. So it's that lower row that we're actually talking about. We're not going to talk about just sort of generic high wind events, which happen, 1 to 3 times per year. Extreme non-convective windstorms are rare, but they recur here. They're part of our climatology, and they produce derecho to tornado-like impacts. And this will include everything from severe damage, injuries, loss of life, and prolonged power and infrastructural disruption. All right, so I want to go take you back, because this is one of these things I didn't know about this. I think I'd read about it. I'd read about it a couple times as a kid, but I didn't really have any context for it. So this is October 10, 1949. You see the front page of the newspaper. This is the Pioneer Press. You can see some structural damage. You see, if you look at that sort of middle subhead, it says man killed, scores hurt, and big blow. City crippled. Northwest suffers huge loss. We'll keep going. This is back when, I guess I saw the Jim Dubois on this call, so he'll appreciate. This is back when they used to just show injured people. Like, I'm not going to help you. Let me just get a good picture for the Morning Tribune first of someone who's been crushed by a fallen chimney. Uh, but this was a pretty severe event. So I'm going to show you. You can't read this very well. I mean, I'm going to lean over closely, but this is the log from MSP that morning. And we're going to look at this red box. And here are the times. So we had a wind sustained of 55 miles an hour, gusting to 65 at 11:29. At noon, it was a 51-mile-an-hour sustained, gusting to 79. We were 55 gusting to 89 at 1, 56 gusting to 83 at 2, and 59 gusting to 74 at 3. That is over 3 hours of siren level wind gusts. I mean, the damage here was unbelievable. if you read all of the newspapers, and I can't believe how much I took in from this event, because Pete Boulay is kind of a weather historian, and he keeps everything, and he's connected with other history buffs who study the weather but maybe aren't meteorologists. And there's actually a lot of information available in our office. In normal times, we maintain a physical archive of all the old clippings and postcards and photographs. And there's actually dozens to hundreds of pages to read about this event. And when you put it all together, you get you get an incredible footprint of derecho level damage covering about 2/3, 5/8, somewhere in that neighborhood of the state of Minnesota. We had 100-mile-an-hour gust at Rochester. You saw the 89 in the Twin Cities. There were widespread 75 to 90-mile-per-hour gusts. There were hundreds of poles that were snapped. Not just the wires falling, not just getting pushed over. Trees were snapped. Trees were uprooted. Windows were broken. Structures collapsed. There were buildings in downtown Minneapolis, in particular the Fauché, which was the tallest at the time, was swaying, and people had to be evacuated from it. They were getting seasick from the swaying and the wind. There were docks that were smashed across dozens of lakes. Boats were flipped, and then frequently the boats were piled up on shores. And there were 27 deaths from this regionally, with 4 in Minnesota. What I'm showing on the right is a surface weather map. And you can see, if you can see the faint low off in extreme northwestern Minnesota, that's actually a fairly strong cyclone. It got down to about 966 millibars or so, maybe 965. And then the light shaded area is where there was some damage reported. We saw damage reported from this system out into well onto the plains and then into the Great Lakes. But the most consistent damage and the most intense damage was in a swath from northeast of Omaha up through the Arrowhead of Minnesota, passing through the Twin Cities, Rochester, western Wisconsin, St. Cloud. These areas were hit very, very hard. All right, so 9 years earlier, again, we could guess, what is this that we're looking at here? 9 years before the event, and I give you a hint. It's the Armistice Day blizzard from November 11th or so, 1940. Now, what most people, we all remember this we don't remember it, but it's memorialized because it was a blizzard and it killed a lot of people and it shut down transportation across not just Minnesota, but the region. It produced a really unusual amount of precipitation for November, but it also, and a lot of that came as snow. It also had a kind of famous temperature drop where temperatures fell out of the 40s and 50s. There are sort of myths about temperatures being in the 60s and 70s, but they generally fell out of the 40s and 50s into the single digits and teens. But what a lot of people, and why should we, don't really think about is how important the winds were in this event. This was actually a regional strong to extreme wind event. And there were devastating winds in southeastern Wisconsin, on Lake Michigan, and in northern Illinois. But if you think of the role of the wind in this, it's actually what began the event. It's what started this, it turned it into a disaster. The hunters famously in southeast Minnesota out on their little skiffs that couldn't get off the islands because the winds were too strong. And so the winds either capsized those skiffs or forced the hunters back to their islands in the river, where they then froze to death. It also cut power and communications. And there were sustained winds of 50 miles an hour or greater in Wisconsin, Illinois, and Michigan. So it was probably comparable in some ways, maybe on a slightly more constricted geographic scale, to the one that came 9 years later that I just talked about. There were 59 deaths at sea from capsizing vessels in Lake Michigan, especially. And there was also a tornado outbreak in Iowa and Illinois. This was a very powerful and talented extratropical cyclone. And, again, we think of it as a blizzard, but it was also an intense regional wind event. And then on November 10th, 1998, we have what nobody calls it Wisconsin's October 49 because nobody knows what October 1949 is, but I'm calling it Wisconsin's October of 1949 because I just introduced this audience, probably, maybe some people knew about this, to October of 1949. And here we are looking at a very similar situation displaced to the southeast by, 150, 200 miles. So at the time, this event produced record low pressure in Minnesota, um, and there were brutal winds that developed in Wisconsin. There was 18 hours of sustained, kind of 35 to 50 mile an hour winds. There were these frequent 65 to 75 mile an hour gusts. And then from far southeast Minnesota into the UP of Michigan, there were these 85 mile an hour and higher gusts, including a 93 that was recorded at the Weather Service in La Crosse. And the fatalities and injuries were they they were brutal. I mean, this is what you would expect if you really sat and thought about the kind of danger people would be in if they were exposed to 75 and 85 mile an hour wind gusts for a period of hours. People were blown into the side wall of their home. They were smashed to the ground. They were thrown off of bridges into the Wisconsin River. Um, there was at least one instance of a car being blown into a pedestrian. I mean, these were a lot of blunt trauma, injuries, and deaths. So these are kind of the three big historic weather events. There are actually other ones. There was a from 2010 in late October, we had another one that was, produced a really long duration of kind of borderline extreme level winds, a lot of gusts in the 60 to 80 mile an hour range. You didn't have a lot of those 80, 85, 90 mile an hour gusts, but uh, that was also associated with the new record low pressure that was set in Minnesota, where we got down below 960 millibars. So Walker Ashley and colleagues, among other people, have actually looked at non-convective wind events. It's not well researched in the United States. And, if you go to different places, there's also different mechanisms. On the Front Range, there's a completely different mechanism for producing non-convective winds, or obviously in parts of California on the Pacific coast. But for us here in flyover country and in the Midwest, it's mostly going to be from strong extratropical cyclones. It's also going to be true in the Northeast. And, even though I'm telling you about these events, having sort of discovered them myself just in the last few years, really, this is another case of why Minnesota's weather is kind of the coolest in the world, or in the country anyway, but it's not. We don't have the greatest weather in the country because we're number one at everything. We kind of get there by being number 18 at everything. And the fact that we have everything is what's amazing. There's obviously places with more tornadoes, places with better snowstorms, places with more intense heat, more intense cold. You name it, someone can top us, but there's few places that have the variety at the extremes that we get. And it's the same is true for these non-convective winds, where if there is a belt of extreme non-convective winds, we're not really in it, which is why it's they're more common to the south and east. They're more common in the northeast, where you have more nor'easter type extratropical cyclones that gain all that steam from the baroclinicity that forms between the ocean and the land. But in any case, in building a climatology of these events, Walker, Ashley, and colleagues and there's a few other people who've looked at it, but it's not heavily researched in the United States. Um, looked at, okay, well, how are we going to define these, and what do they do, and where, and where do they kill people? And so these are the source of death for the 26-year period here from 80 to 2005. You see a lot of people are outside, and they're in their car, or the tree falls on them when they're outside, or they're in a vehicle, or even in a boat. There are a lot of folks at construction sites. People get hit by flying debris. It's a little different because in a lot of cases, um, while the extreme winds are occurring, the skies might be clear or partly cloudy. Um, the the part of the low pressure system where you find these winds is usually not really burdened by heavy precipitation, even though, but we'll get to that in a minute. So a lot of times people think it's fine to be outside, and they'll go outside, they'll do what they're planning to do, and they'll ultimately pay a price because of these extreme non-convective winds. Here's the distribution. Now this is as much a map of where extratropical cyclones, or where non-convective wind events reach certain extremes, as it is a map of where people are in regions that get extreme non-convective wind events. I wouldn't make too much of the all the dots in southwestern California, but in the Northeast US, that's obviously a combination of dense population and high frequency of very strong extratropical cyclones. By and large, the majority of research on these events is for Europe, for Northern Europe, areas that get ravaged regularly by very powerful winds. And it just, for whatever reason, hasn't risen to the level of concern that it's become a big academic or scientific issue for the big R research community in the United States. There's been a few people, Walker Ashley, John Knox, Aya Capelli, there's a few others, but a lot of the research is done for Northern Europe, for the North Atlantic Ocean. I would also assume that there would be some really interesting findings if we looked at these in the Gulf of Alaska, where you also get very powerful cyclones. So I just want to kind of turn and talk briefly anyway about these, what little science has been done on these types of events. So here we're back to November of 1998. This was a vicious day, and that's a nice, iconic satellite photo that I think everyone on this call recognizes. It's beautiful, comma shaped. I want you to look here. Look at that little, I mean, this is something we've all seen before, right? And this, but what is this? This is same, this is November 10th of 98. What is this little critter here? Well, this is something that Aya Capelli and Knox defined as a mesoscale dry hook. Now, the mesoscale dry hook, they believe they have identified a sort of rush of highly stable air that descends right out of the high troposphere and stratosphere, and they were able to use satellite products to detect ground level ozone in the vicinity of some of these features. Now, this is where I think scientifically it gets a little bit dicey, because the mechanisms, I mean, there was a review paper written in 2018 on everything that's known about the sort of mechanisms behind these events, and there's still some uncertainty, and there's clearly still some confusion among the mostly British and European scientists who really study these most intensively. But the idea is, in any case, you will often find one of these little features. This is associated with a hook shaped path of really intense winds that went right through the same region. So there are the intense wind reports. Again, a lot of these were 75 to 85 and even 93 mph gusts in this little swath where that hook-shaped feature passed. And you can see from other cyclones, this was a different one just a few years back. There it is again. This one produced strong non-convective winds and some damage in Iowa and Missouri. Didn't really produce many impacts here in Minnesota. So there's some question about whether it's a mesoscale dry hook or a sting jet. In the literature, they're not necessarily used interchangeably, but for all, I guess, all practical purposes, since the mechanism doesn't seem to be known perfectly, I think you can almost call them the same thing. A sting jet, um, if, not to get too meteorological for those on the call who maybe aren't meteorologists, but essentially you've got the kind of inside the cyclonic circulation, you've got this frontolytic region, right, where the front is not maintaining its intensity and is actually collapsing a little bit. In other regions of frontogenesis to the north of the cyclone, and if you look at on the satellite imagery, the sting jet is often, it's not that sort of cleared out hook shape thing that Iacopelli and Knox had identified, but the sting jet is actually going to be associated with the cloud material itself and is so named sting jet because it's kind of shaped like a scorpion's tail. Everything in meteorology always comes back to weird non-scientific explanations, but I'm fine with that. Um, but there's this question of, well, what process is driving these? And really, I'm not sure if I care, because here's what we know. The strongest, if one of these events is going to produce extreme non-convective winds, they are going to be to the south of the cyclone, where that mesoscale dry hook is wrapping into the circulation, and or where you will find that supposed sting jet in the frontolytic region, where usually there's not much precipitation and the skies are often, fairish. Um, the other thing that you will find with these is there's extremely low pressure. You can get damaging winds and, kind of generically high winds at, um, from a strong pressure gradient with only a marginally strong cyclone, 980 millibars maybe. But these events, when we looked at the ones where it was lights out, they all have pressure in the 970s or lower, and usually it's the low 970s or lower. They're events that were, kind of near the top in terms of regional intensity. Uh, and again, that wind is going to be on the south. The strongest wind is going to be to the south of the actual center of low pressure. So it's not the same as what you expect behind a low pressure system when you get the really strong winds, from a typical winter storm. It's a different mechanism. And there are people on this call for sure who know a lot more about meteorology than me. So I'm just going to shut up about mechanisms and just say, we know enough to know that if you're going to be at risk, it's probably because there's a low passing somewhere to your north or northwest, and it is powerful. So here's a very crude, based on, I think I assembled about, it was maybe 30 different cases in the US, but only a hand in the middle of the US, but only about, 8 or 9 of them actually qualified as this sort of extreme level. A lot of them were just kind of high-end, high wind events. And so I actually have a separate grid for those, but this is just a very crude rubric where, if the pressure at the lowest is 980 millibars or higher, we really don't tend to see that extraordinary level of wind. I know there are other things that could happen that could enhance wind. It's not all just based on the lowest pressure in the middle of a cyclone, but by and large, if central low pressure doesn't get below 980, it's unlikely that you're going to see extreme winds. Now, as the pressure drops, you see that it becomes more likely, but you've also got on this table sort of distances, and you're really most vulnerable. You're kind of in that sweet spot. Definitely if you're within 500 miles and certainly within 300 miles of the center of a low that is 972 millibars or deeper. I'm basically saying it's got to be one of the strongest cyclones you'll ever see in the Midwest. But we do get those. They do happen. I'm kind of surprised from the winter of 2000, 2001 when we had a couple, maybe a few of those, and from February through April. I'm a little surprised we didn't have more of those types of events because we had a couple that were right around 972, 974 that spring. But in any case, this is kind of what we, so importantly, you need to be, the cyclone basically needs to pass northwest or north of you. Um, and so the different distances are basically stratified on whether that cyclone is passing north or northwest of you or not. You still could get some really strong winds if it doesn't, because of the powerful pressure gradient that you'd expect at pressure levels that low, when the pressure is that low. But the sweet spot is definitely that pocket to the south and southeast of the very deep low pressure system. I'm not sure how much else I have here. One of the things that also thought about, and this is pretty generic and could use some improvement, but there's sort of 4 different brands or modes that I was able to find. And I did not subject this to like cluster analysis or doing anything statistical. I mean, this is all really just like put a bunch of stuff in a kitchen sink and then look at it and then try and sort it out and make sense of it. And what I came up with, so there's typically, and you can kind of think of a cyclogenesis type of situation, or bombogenesis. I hate that word, but type of situation. If you're going to get the extreme winds, most of the time, nothing really interesting is happening right where you are before. And half the time, nothing is really happening where you are after the extreme winds. So in most of those cases, you don't have to worry too much about, say, cascading issues, because but look at scenario 3 and 4 where you get the extreme winds. And I didn't mention seasonality. For us, our peak season here is really October, November. So we don't get too much in the way of really brutal cold. But one event I didn't touch on was from November 10th and 11th of 1911, which is another one that everybody should know about, because the temperature dropped so fast. It was a little south of us. It was mostly Wisconsin and into Illinois, but it was an absolutely stunning temperature drop, plus extreme winds, and then a blizzard. And oh yeah, it started out with an F4 equivalent tornado in Janesville, Wisconsin. So pretty nasty. And depending on where you are, any one cyclone could actually possess multiple different scenarios. But you'd obviously be concerned if you're in scenario 2, where you get severe weather first, like a tornado outbreak, and you lose a lot of infrastructure or a lot of communications, and then you get a sustained extreme wind event after that. That would be really problematic. Um, I didn't find any cases in our region anyway where you went severe weather, then extreme winds, and then blizzard, but I'm sure that that's possible, but it doesn't seem probable. Um, and I think if I play it safely, I can pretend to make a smooth transition and now take you to the next slide. So if anyone has any questions about this, I guess now would be a good time, Jared.
There was a question or two from Brad Nelson here. I'm just going to back up the chat a bit. On slide 20,
Okay.
yes, what does the vehicle other actually include? ATVs, motorcycles, skaters, and that 25%.
Yeah, I'm guessing that it's, yeah, undefined whether they were in a car or a truck or a motorcycle. So
Sure.
I would assume it's that. This is all, you know, um, when I'm not in the heads of Walker Ashley and Alan Black, but I think what they had to do was sort through kind of secondary resources like I did. And they're pulling together from various databases and from some sort of secondary accounts from newspapers, possibly, maybe from insurance reports, as much information as they could. And sometimes that can be vague. So I am assuming that they put the vehicle comma other in there to cover the fact that they don't always know if someone was in a covered vehicle or if they were in, on an ATV. It's a good question.
And then to follow that up, also from Brad here, a few slides later. Let's see. Keep going. Right. Yep, right there. Actually, that'd probably be a good one with the
Okay.
dual graphics. He's asking about that. Your thoughts on it? I guess he says seems like a slingshot around the base of the cyclone where the strongest pressure gradient would be. And to me, that I had responded to him, that kind of mimics what you see with tornado cyclogenesis, where you get the rear flank downdraft coming around and you get increased flow and the tornado will intensify. What are your thoughts on that?
Well, that's a really interesting thought. Yeah. So, to what extent is this a macro scale version of what you find around a mesocyclone? I just want to be intellectually honest and say I hadn't thought that through mechanistically. It's a really good question, Brad. Um, Generally, this uh, if this helps at all, and it probably won't. From what I can tell, not only are these sort of flows and these events associated with really powerhouse cyclones, but they're also it tends to happen as they're hitting bottom. Uh, so it's in those final hours of bombogenesis where the pressure's not falling as fast anymore, and it's starting to 972, 971, 970.5, 970, and it's then for a 10 to 20 hour period in there roughly, sort of while it's at near maximum intensity. So I'm just thinking sort of dynamically and physically about that. That's when all of the sort of conveyor belts that feed in would be essentially um, maximized and or almost exhausted too. I don't know if that helps, Jared, with your conceptual model for a mesocyclone, but um, some of the flows would be pretty mature at that point, and it's only kind of in the final. Yeah, this is like one thing that hadn't happened yet was that all of this fantastically dynamic air descended. And I think it is, my understanding is it's a little more than the pressure gradient than you would see at the surface. There's a dynamic kinematic effect here too because of the moist and dry air processes wrapping into the cyclone. So it's
So,
I can refer people to more
Kenny,
studies that have looked at it dynamically.
where do you see that visual like representation start to occur?
Mm.
Is it always on the southwest or south side, or do you see that rotate around the parent cyclone
Mm.
usually?
That's in my observation. So you're talking about the image we're looking at right now.
Right. Yep. Yep.
So in my observation, the system becomes too distended and occluded once it gets more wrapped up than this, right? Because think of how dependent it is on the flow of moist air into the center of the cyclone, and once you start pulling in all of this dry air, then you're pushing the moisture feed out away from the center of the cyclone, and that is essentially the beginning of cyclolysis, which is my least favorite part of um, any cyclone's life cycle. It makes me so sad. All the good times have ended then. But Not because of human suffering. No, not because of that. Just because, I think climatologically, meteorologically, this is when it's all very exciting. And this is when, you know, if you're working one of these events in whatever sector, this is where the data coming across are blowing your mind. Like, whoa, we just got a 87-mile-an-hour gust. What? Visibility is down to, less than a 16th of a mile and blowing dust. I mean, um, but just to make sure I think I understood your question, I don't see it wrapping around much without also killing the cyclone and then shutting down the dynamic processes that are dependent on the intensity of the cyclone. I haven't seen it happen. Now, it might be a very different story when this kind of system goes out over the ocean, and because then there's not the same, because dry means something very different. So I haven't looked in depth at what happens over the North Atlantic when you get these, 960 millibar cyclones, and if they have a little more life after kind of this moment here than we do here.
Um,
I'd be interested in anyone else's thoughts, by the way. I don't own this other than bringing up the topic. I was kind of hoping there'd be some meteorologists who wanted to try and figure some of it out. And I'd be happy to send papers to people too. I know that there's a lot of folks on this meeting who are smarter than me. So I'd be happy to push information people's way.
there is some additional questions from Hunter on it, and I think you probably touched on some of what he wanted to hear. So, Hunter, if you want to turn your audio on there and maybe express what other questions you had for him.
You guys copy?
Yeah, I got you.
Cool. I guess really just looking at maybe I'm thinking more synoptically based here, but when you mention the regions of around that sting jet area, and you have, it looks like with your one graphic, you have your frontogenesis to the north and your frontalysis to the south. Or actually, oh, you still have your frontogenesis to the south too, but frontalysis right in that immediate region then. I mean, ideally, if you have frontalysis and frontogenesis occurring in close proximity to each other, wouldn't that also increase your gradient as well, or at least enhance that region? I mean, it looks like your region of frontalysis is surrounded to the north and south by frontogenesis, so it looks like that region right there is then enhanced where that sting jet is located. I don't know. I mean, I'm not an expert at this at all. It's just, I guess it's more seeing an observation and further further analysis. But
yeah, no, I think that's a great point, and I don't have any reason to doubt that you're correct. I'm trying to kind of think it through here.
Yeah.
And I don't want to waste everyone's time with me thinking like, okay, frontalysis, but yeah, I mean, so if you just think of the flows kind of from the mid-troposphere down that you find around a strong cyclone, you've got sort of the moist region, you've got the main temperature advection out ahead of that, so it's the warm sector, and then behind the cold front. What happens after the front passes, when you wrapped so much air around, is you've essentially got dry air, and there's no real, so it's sort of cut off, or it's severed from its original source,
Yep.
right? And so as I understand it, and this is the part where the British meteorologists and the Norwegian meteorologists are going, they're having a good time. So they're taking moist processes, and then they're advecting that moisture and they're essentially advecting it into this dry stream, where then you get this sort of rapid evaporation, and that's where a lot of the descent happens.
Sure.
And so it's some of the momentum then that's transferred downward from, I'm not sure what level we're talking about, but
Yeah.
you've got often you've got pretty vicious flows up at, even 700, let alone 500 millibars right above
Yeah.
that spot. So if
Awesome,
anyone else
thank you.
has, yeah, sure. If anyone else has thoughts on this, I mean, I was kind of hoping, there've been a couple times on NWS chat where I've, big cyclones coming in and I've tried to tease this up, and I don't know if, professional meteorologists have to think about this because it's not that common here in Minnesota. And I don't know how, if everyone's reading every single issue cover to cover of weather and forecasting. It would be, on one hand, it would be easy to maybe miss some of this. And on the other hand, I wouldn't be surprised if people already knew a lot about it. And I just never hear anyone talking about it.
I have a question, if you don't mind.
Yeah, please.
Actually, observation question. First, on the slide talking about the 1949 event, I think it was right before the Armistice Day. It looked like there's a typo on there.
Oh, I'm sure.
Before this one, yeah. No, there. Don't move. The one with the map.
Yeah,
There.
okay.
In the
Typo.
box, it says
Oh,
October 10th, 1940.
1940.
Yeah.
Yeah, that's incorrect. That's it's like a portmanteau of two great weather events. Like let me just take the 1949 and merge it with Armistice Day.
Sure,
They
no
had
one
a
will
baby.
notice. But my real question is, have you looked at, or from what you've seen, at 500 millibars, where something like this would appear in the long wave trough or ridge? I assume trough.
Yeah, it's going to be a trough. I haven't looked closely, but I'm going to assume, so it's going to be somewhat downwind of a pretty diggy trough, right? I mean, it's going to be in the divergent region, because in order to get powerful cyclogenesis, you have to have that appropriate ventilation aloft to, allow your surface pressure to drop. So, but no, I haven't done like a climatology of that, because at root, I was looking at this first as a sort of someone trying to help emergency managers, which is why I came up with that wacky, because I thought, well, geez, if this is something that nobody talks about, then I can't assume, oh, and by the way, when these happen, um, forecast wind gusts and wind advisories and high wind warnings sort of bust majestically. No one's ever saying, oh, gusts up to 93 miles an hour. Like, that was not in the forecast at La Crosse. So when you do see these, they tend to be a little under forecast. And so I was producing this information so that, with this idea that, if this kind of event unfolds, we might not get a lot of lead time or a lot of heads up on it, because it's not something that's talked about or thought about much. So here's something really basic that a bad meteorologist like me can sort of use to rely on. And if I see these things coming, I'll let everyone I know kind of know, and maybe they can check it out. But so I wasn't doing it to sort of build like a full-on meteorological model of how it works in our region. And then secondarily, sort of as a climatologist, I wanted to get a sense of, well, okay, what's a typical recurrence of these sorts of things? So some of the really interesting dynamical questions about these events I haven't even ventured into. So it's a really good question, but no answer here.
Thanks.
Yeah.
Excellent. Did you have more for us, Kenny? It sounded like you were at kind of a breaking point into some other material.
No, I think we're good. I've spoken a lot. I've talked a lot. I've taken up a lot of time. Anybody who has ideas or wants information, I'd be happy to share what I have. I've got kind of a small starter literature review that, bibliography of papers that you might want to check out. Again, unfortunately, most of the really cool stuff has been done for, you have to orient yourself. All these maps are out over the ocean, or they've got like one little piece of land in the ocean. They're not what we're all used to looking at, but there has been some, I'd say a small amount of published research in the US. And again, I don't know, how much forecasters have shared with each other about these. I haven't seen a tremendous amount.
All right. Anybody have any final questions for Kim?
Did anyone guess 1983 on that original?
Yes.
Oh, these are some good.
There were Jim Dubois, and I think it's one of the Johns here. I gotta go back.
Oh, something 83 or 84.
Yeah. John Letter. So
It's crazy to me, Kenny, to think about like that these events occur. These are really extreme events that if they happen now, you think about 90 mile per hour winds, and what could happen now with all the population boom and everything, and they're going to happen going forward. I mean,
yeah,
you got to be prepared for that. I mean, every 10, 15, 20 years, whatever, it's going to happen, right? I mean,
yeah. And I don't know if you're talking about one of these extreme non-convective events or something like July 3rd, 1983, but you're right on both counts. They're both parts of our climatology that have a recurrence. So they're both rare. So people forget. I've been working with Hennepin County since 2014, basically. And they got a mesonet that they started deploying under Sarah Carroll's leadership in 2015. And I think it's been beefed up substantially by Emily since then. And I think the highest gust we've seen is something like 69 miles an hour. And we were pretty excited about it. It was like, whoa, and we had 69. It was on that it was this is June 11th, 2017, when there's a wind-driven hail event in the morning. And it was that was the strongest wind we've had. We haven't seen siren category winds, let alone 90 or 100 miles an hour. So yeah, I mean, I think that it's hard to know what it's going to be like when that kind of thing does happen, but it's foolish to assume it won't happen.
kind of like the cold in Texas that we just recently, it happens, right? I mean, it's climatologically every decade, right? You get some sort of cold push like that, and yeah, you got to be ready for it.
Yeah, I agree.
Low frequency, high impact events that happen.
Yeah.
And if this hits in the wrong place or right place, you're going to end up with $1 billion disaster. It seems like with everything we've got is that, but just from a 5-hour sustained hurricane force winds in the upper Midwest.
So the October 10, 1949 has a current price tag of a little north of 100 million. Now that's not, you can't really do that though, because the population was half, right? And we didn't cover as much territory. So so that's just crudely inflating the numbers of the actual losses at the time. You come up with like 118 million or something like that. It would definitely be a expensive, costly, and potentially tragic. I mean, we all think that situational awareness is so bad during severe weather, wait till we see how unprepared people are for like a clear day with deadly winds. Oy.
And like you said, they would tend to under forecast this stuff. So they might be saying, yeah, gust to 40, but whoa, it's gust to 80.
Yeah. I mean, that's the part that's where I kind of hope that the meteorologists who can, I think, have the tools to figure it out. I really do. I mean, I think that between really reading the science and what some of the dynamical forecast indicators are, and just familiarizing themselves with some of these things, I think they might be able to get ahead of that, and do some good. But currently, they're always under forecast. Nobody sees, I think that I remember seeing the first presentation I saw that was about extreme non-convective winds. They had some of the forecast snippets from the day before, and I think gusts up to 50 miles an hour had been forecast in southwest Wisconsin. Nobody was expecting that,
Yeah, we would never forecast that, but at
right.
least they could be a little closer is what we're kind of aiming for, right?
Yeah, I mean, you'd be laughed out of the room. Gusts up to
Yeah,
93 miles an
93
hour.
miles an hour. Are you kidding me? Like, you're right.
Yeah, yeah.
I think
Yeah, and
that's
they,
where your chart, Kenny, of the millibar level and in relation to how far from the low could be maybe a useful baseline for stuff
yeah.
like that.
I mean, it's pretty sort of arm wavy back of the envelope too, right? I mean, I looked at a bunch of cases and I put some pieces together. I think that real forecasters could probably do better than that, but if it's a starting point, I mean, I tell you, any cyclone that gets into the low 970s, you got to start thinking about not just really intense gradient winds, but is it, winds generated by the gradient itself, but is it going to get one of these boosts from, you know, sting jet type? Isn't a sting jet a great term too? It's nasty sounding. Just sounds, it's going
Love
to
it.
hurt. Yeah, it's going to hurt.
Scorpion.
Yeah. So, yeah. So send me an email here. Jared, put my email in the chat here just in case.
Sure.
And I'd be happy to just swap stories too. We eat this stuff up. Um, yeah, and on the actual files that we have on this, there the pictures of the boats piled up downwind of Lake Minnetonka is unbelievable. It's like piles of boats that go 30, 40, 50 yards in. It's amazing.
Yeah. Can you imagine that scenario in like let's say it's September when people still have their boats on Minnetonka and you have these multi-million-dollar
100-mile-an-hour
houses.
winds.
Yeah, and their yachts being out there, like them just getting all piled up. I think that would far supersede even exponentially amounts of what we saw in the earlier one. I can't imagine. I mean, one household could have like $2-3 million worth of damage. It really easy, just losing a 40, 20, 30 foot yacht and then, damage to their whole exterior and stuff. I mean, it could be pretty bad.
Yeah. Yeah. I mean, and they're going to be, it's pretty easy for winds to pick up and flip over a dock if you don't have the dock secured really, really well. Docks get mangled and flipped over all the time with 60, 65 mile an hour winds. If there's anything about the lake that's actually enhancing the winds locally, in addition to any sting jet type of feature, that could spell real trouble. You could have some aqua projectiles. Now you got flying boats. So
yeah, Kenny, I think one of the most interesting pieces what you mentioned there is that what is the warning paradigm around that? Is like a high wind warning. Who cares if that was what you went with? I remember here, gosh, maybe somewhere in the 5 to 10 year ago ballpark. I remember out in Montana, Glasgow went with, 70 plus tagged severe thunderstorm warnings for really like an enhancement type of an outflow boundary type of a thing, because they went back and said, like, yeah, it wasn't convective, but we used severe thunderstorm warnings TAG 70 plus because we knew that would at least get some sort of alerts out there. A high wind warning who no one would have even noticed until it was done, kind of a thing. So I think that's certainly a interesting piece of it too, is just what does that warning paradigm even look like to do it, you know, both from eliciting a reaction, but also being true to the meteorology side of it.
I would love to know from folks who are working in, I wonder, I don't think Seth was at the, I wonder if we know anyone from La Crosse who was working there. I bet Jeff Boyne was working that, and in November of '98. But I would love to know what products they wish they could have used at that time, because that was their own instrument that hit 93. And I think they were, what the heck is going on? And how do you shelter for 5 hours? I mean, what do you do?
It's
Yeah.
almost like you need a PDS high wind warning.
Yeah. Oh, wow. You know, I thought the Weather Service was trying to simplify the
Yeah.
watch warning advisory. But yeah, it's
Essentially, they're just putting it all into the metadata. I mean, there's no
right.
simplification there. It's just transferring it into the metadata. That's all we're doing.
Yeah. Well, it's so we're in the season now. It's more common in the fall, but we do occasionally get them in the spring. Let's say 1 out of 5 of the ones 1 out of 4 of the extreme ones, I guess, are springtime events. But yeah, watch those 970 something lows. Whew. Just keep an eye on them.
So, Kenny, what do you think it is about fall versus spring? What would the dynamic considerations be there that push more of those events into November instead of March?
I think that I guess I've always assumed that the reason they're stronger in the fall is that the uh, sort of the cold advection feeding the baroclinicity is a stronger, like it's such an important driver. You know, if you've ever watched cyclogenesis, I don't know why I like to do this, but I just love when you've got a really good temperature gradient building and then a wave passes over it and you can watch cyclogenesis. It's always really, really excited in front of a kind of a razor sharp cold front. And so it just seems a little more, I mean, spring's got these excellent things working for it, right? I mean, you've got the flow of warm air coming up from the south and it's invading a fairly cold upper atmosphere. I mean, that's great. But I think there's just something about that just having that mass of cold air plunging down to provide contrast. And it's often it's also kind of it's sort of breaking the air mass for the first time. A lot of these events are sort of first breakers, which is kind of interesting too, where it had been in the 60s, 70s, 80s before them. And then it's, now you're really into fall. And the transition is this one kind of cataclysmic system.
I just have one theory on this, and then I know I gotta get going soon myself. But what I'm thinking, because the fall, one thing that you have to think about, usually it's warmer aloft in the fall, and then it gradually decreases as you go into the winter. What if some of this air is basically trying to travel above that relatively warm layer, and then all of a sudden it just gets forced down, almost like bouncing off, like a gravity wave bouncing off a stable layer.
I like that. I don't have a retort for that. That's good.
I mean, does anybody else agree with that? I mean, it seems like, something's forcing it to go down, and it's like, wouldn't that be the way to do it?
Maybe a secondary circulation or a ageostrophic flow around a jet that could force it down.
I mean, I was just thinking generally climatologically speaking. Usually it's warm. Usually in the fall it's warmer aloft and then getting cooler. Where in the springtime it's usually cool aloft and getting warmer with time. So that's why you probably see, that's why you would see like your bigger severe convective events, because because convection is basically cooling off with time, where cooling off as you go up, where fall you're basically seeing more stable events come up because you're basically warmer aloft than you are at the surface, relatively speaking.
That is true, but it's also true that in fall you're seeing the first of those really cold, the first appearance of the really cold air aloft arriving, usually right around that time. So you've got your surface baroclinic zone, but you also have kind of something similar happening up at 500. Take your pick, right? As that, you know, I think that you get that sort of -20 type, -30 type stuff up there. It comes in really the first time you see the really cold air tends to be, I don't know, I guess late October, early November, right? And that's where you start to put some meat on the bones of any forming cyclone. It's like, oh, it's got something to work with now. It's fully, you know, it's not just a little cold front, but it's fully integrated cold air. It's a good thought. I just have to think. I'd have to think more about, you know, why it's. I shouldn't claim to know.
I wonder if they tend to happen more severely, you know, or we get those extreme winds in the fall, simply because the bulk of land is really just warmer. You know, the spring you talk about, we have snow cover a lot of times, and the ground itself is a lot colder. So the air mass near the ground is generally kind of cool unless we get, you know, some real good moisture coming up from the Gulf. Whereas in the fall, your ground's still cooling down and you have slightly warmer air to deal with. I would think that would have something to play a role in it.
Yeah, I mean, I'm thinking about, you know, what's so interesting about these is they almost all. So I just went and looked in the big green book, the significant tornadoes, and sure enough, there's significant tornadoes in Kansas and Nebraska and Missouri on October 9th, 1949. All of these systems, I mean, in order to get a cyclone at that intensity, you just have to have a lot of things come together, and that's going to mean converging moisture into a powerful region of lift and strong temperature advection of possibly both types. And so I think the question that I struggle with is just that I hadn't really thought about in depth is just why would that whole thing, even though we get the ingredients for severe weather much more frequently in the spring, and it's pretty dependable, right? Especially coming up from in the deep south right around now through April. And then, but yet these systems seem to have a little more ferocity, and are yet just as dependable for severe weather, but in the fall. I don't know why. I'd have to dig deeper into the literature on it.
Did you happen to look at the surface maps for the previous days to see when they had those tornadoes? Was the low located down to our southwest then, and it moved up over our area?
Yeah, to the best of my ability, the tornadoes were for the most part right where you would expect them in a forming, you know, strong low pressure system. So, but also the day with the tornadoes, the pressure's up in the 980s. It's a bit higher, and then it's dropping. I mean, I'm sure in some of those cases you had tornadoes still in the warm sector as this thing is bombing out, but you know, once it really gets into that kind of mature phase, the cold front or the occluded front is going to be pushed pretty far out east from the low pressure at that point. And so then you'll see more squall line type stuff and the moisture convergence will be weaker. So I could do this all night, guys. I'd love to, but I gotta probably call it here. But please send questions to me. I'm loving these comments. It's great to see some familiar faces, and thanks.
Yeah, I think the group that's left here knows how to get a hold of you. If not, your emails in the
Great.
chat. So
Very
I'm
good.
ready to call it a night too. Thanks so
All right.
much, Kenny. Again,
Yeah.
it's great presentation. Always love hearing stuff. So
Well, I'm happy we did this, and I'm glad I was able to pull something together. I was making myself a little nervous. I kept adding slides and things, and then I thought, you know what? I'm just gonna talk, and then when it seems like I'm done, I'm gonna stop, and that's what we did. So,
well, I'm happy with what we got, and I'll get your umbrella speaker gift in the mail here in the next couple days. So
right. Many thanks. It was great to see everybody. Have a good night, and may the storms be with you.
one can hope.
Yeah, thanks, Kenny. Hey, and for all the severe weather freaks still on the line, don't forget about the Iowa conference coming up the end of March. They're doing it virtual this year, and it's the 10th anniversary of the super outbreak. So they've got several folks from down southeast, and then of course talking about the Iowa derecho. So
Yeah, and I think late registration starts. What is it? March 1st or something. It's $20. I mean, just go buy.
it's open right now. It's open right now. So yeah, $20 for student registration, $10. So
Did everyone see video of the Iowa derecho? Have you
Yeah.
seen
Oh
video
yeah,
of it? What's
especially
up with
that.
the 45 minutes of intense winds? What on earth is up with that?
yeah.
Yep, just crazy. I can't wait for Rich's stuff next month. I don't know.
I'd love to get Dan Miller's take on that from like the extreme damaging wind perspective, kind of his work around that. I'd be interested now. He's out in Portland.
Portland.